I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey, Ben.
Hey, Matt.
How you doing, my friend?
I'm working. I'm working today.
You're working?
Yeah.
Why would you do such a thing?
Doing the day job. I am staring at a bunch of comments in my code that are like, "Hey, Ben. Hey, later, Ben."
Yeah,
comments written
Ben.
by earlier Ben. Yeah, past Ben. Hey, future Ben. You need to solve this problem. So, solve this problem. And now I'm looking at these comments being future Ben going, yeah, I guess I got to solve this problem now.
Well, I'd tell you what, that past Ben had a lot of confidence in you. Misplaced? Was it misplaced confidence?
Hopefully not.
So this is an interesting, actually, in sort of the taxonomy of comments. There are like say what you're doing, which is almost always a mistake to say,
right.
Hey, add 3, the comment says, add 3 to the blah variable. And
yes.
you're like, it does, and then you know that underneath it, blah variable plus equals 4 is what it's inevitably going to say, right?
Yes,
because
yes.
the comment rots. So, one typically says, well, if you can't make it obvious by writing the code, so that it reads like what you want it to say, then you've probably got a problem with your code. But then there's the why explanation, which is like, hey, I am doing this because of this thing that's not obvious from the context or the code or whatever. Those are okay. But then this is the insert code here. This doesn't do anything yet version of the comment.
Yes.
So what is the problem?
This is my task tracking style of comment. I actually do this thing where we might have talked about this actually, where I have a special check in branch builds for to-do comments. So to-do means something very special in this project. And it is basically like, I've queued up some work that I need to do, and you can't merge to the main branch if you've got any of these things left in the code.
Interesting. That's a good discipline to have.
Yeah, and it's actually also a great way to collaborate, because you can sit down with somebody and kind of like put some to-do comments in the code and be like, oh, we need to fix this, we need to fix this, we need to fix this, and not lose track of the fact that as a group you need to do this work.
That's interesting. I've worked on projects before where we've not allowed to-dos to be merged into main. Like essentially we can't promote anything to production if it has any to-dos in it. But nowadays I subscribe more to provided the to-do has a tracking issue associated with where like the finesse of like why it's okay to defer it for now, and it can be scheduled and put back on like someone's work to-do list, actual list, then it's okay. But it might be nice to have like both worlds where you're like, this is a long-term to do, like, hey, to do, we know that this doesn't scale, but for the next year it's likely to be okay. Eventually we're going to have to replace this order n squared algorithm with something cleverer, right? That's the kind of thing you can put in a to-do comment, obviously until you forget about it and then everything falls over because it's too slow. But that's the whole point of having the tracking issue. But then this to do is like, no, I just want to be able to commit so that someone else can pull the branch we're collaborating on, and we can't get this into main. Yeah. Right. And
it will not accidentally go into production without having looked at this. Yeah.
Right. We on the other end, I have pre-commit hooks that say if it says do not commit anywhere in my repository, then that you can't do that. But do not merge is something I have written, but I have nothing that prevents it from being merged into main. It's just like a convention there, and you hope that when you're diffing things, you'll go, oh, whoops, I shouldn't do that. So maybe we should enforce that. Anyway, that's not why you wanted to talk about this stuff.
So what is this comment? What is this to-do comment? So basically the problem that I have here is I have a sort of unknown, you can think of it as a directory structure. This is actually in S3 storage, but we're treating keys like directories in S3, and that all works just fine.
Really.
Yes, it all works just fine. So you have this sort of unknown directory structure, right?
Okay. Yep.
So there's some root path, some root key that but underneath that you have some heterogeneous mix of files. And what you're trying to...
And subdirectories as well?
Yes.
Files and subdirectories.
Potentially many layers of subdirectories, right? And you have no idea what the structure is. And what you're looking for is files, and for the sake of simplicity, let's just say that they're all of one type. Let's say CSV files. So you're looking for CSV files that have the same base path. So one of the subdirectories in the hierarchy of subdirectories that is common contains underneath it a homogeneous set of CSV files, all with the same schema, right? So they can be in different subdirectories. And an example of this would be like separated out by date, right?
Okay.
So maybe you have something where it's like, you've got a base path, and then under that you've got a subdirectory per day, and then in each of those days you have a handful of CSV files, and you want to be able to detect that base path has all these different files, and they all have the same schema, and there are no other files in there that have a different schema. So the part of this problem that I've already solved is a sort of schema detection. So I already have an algorithm where you can, take basically a stream and send it in there and be like, hey, this is a CSV file. I want you to inspect the headers. I want you to inspect the actual values in the CSV file to make sure that they're, detect what the types are.
Like noneness or otherwise of them, or date times or strings or whatever.
Yeah. It's sort of like it devolves into string, right? It's sort of like, if I can't figure out what this is, I'm just going to call it a string, right? But if I can parse it as, a date time or a float or a 64-bit integer or a 32-bit integer, like that's what the type is going to be.
Derived types. But you infer it. Yeah, anyway, but that's the solved part of this
that's
problem.
already done. So that works. So now what I have is the algorithm that I need to implement here is you're given a bucket, an S3 bucket. You're given a prefix within that bucket. And now you have to scan that prefix and come up with a list of schemas where the schema contains the results from the inspector, so like the columns and the types, but more importantly, the paths. And the tricky bit here is if you have something, it's entirely possible that you scan this and you come up with an empty list, because if the structure that you're given is just a hodgepodge of heterogeneous file types, and there is no root key that gives you a homogeneous set, then there's nothing to do here, because what we're producing from this is basically a queryable table where you can give it that path prefix and say everything underneath this has this schema, has this type.
Okay. So you're trying to find the highest point, treating it like a graph with leaf nodes where the files are. You want to find the highest point where all children leaf nodes that you can find from that point have the same schema, and then you want to find the set of the highest points where there are different schemas. Is that fair to say?
Yes.
So if you had so a directory A and a directory B, and A, then under A is all these dated directories, so A slash 2023 04 14 slash some other thing slash whatever thing, and then there's a file.csv. And if you could say, like, well, all of the files for all the days, for all the measures under this root under A have the schema where it's a date time and a value.
Yeah, right? There's 3 columns with these names and these types, and they're all the same. Yes, exactly.
Across the whole of that. And then, but conversely, on the B bucket, there's a different set of things because it's maybe a completely different set of data. But you don't know that information a priori.
Exactly.
So you just yeah, that's an interesting problem. And there are some sort of S3 specifics that I can think of that would either make this easier or harder. And depending on how efficient it needs to be, that's also a question to consider, right? Parallelism or otherwise. So I'm going to think out loud at you and see where we go from there. But interrupt me if I'm gibbering too much. So logically, you can just ask S3, give me a dump of everything you have. And it will just start from A and give you every single giant long path name of everything. Because really, under the hood, it's just a key value store where the key is the path and the value is the contents of the thing.
So that I have implemented. I have basically a recursive search from the prefix where it will walk recursively and give you
well, that's the
all
trick.
Of the
you don't.
thing.
Yeah, you don't have to do that recursion because if
I'm not
S3,
doing it. Yeah,
you're just saying
the S3 client is doing that for me. Yeah.
And it's not even doing it right. The client's not doing it either, right? The way S3 works is if you give it a delimiter, it will use that as a point to stop, which will then mean that necessarily you'll hit each level of the directory. But if you don't give it a delimiter at all, it just does it flat out listing the keys with so there's no sort of hierarchy except the hierarchy that you put on top of it by saying, by the way, the / is magic to me.
Right.
Although
yeah, you're just listing all the keys that start with that prefix. It's really nothing more than that.
Exactly.
Yeah,
so you could go the route where you do that, which is efficient from the point of view of just paging through the results from S3 and you get this giant list of things. But it's also, you then kind of want to re-infer afterwards the structure of the directories having given this list of things. So you could treat it like a tree. And so for every one of those nodes, you construct a tree in memory for each directory. And the directory has children. And the children may be other directories or they may be files. And files have schemas, right? Or you could just treat it as a schema, right? And then it maybe flows naturally from that. So if you've got it all in memory, which may be not feasible given the scale that you're working at.
I think it's okay to have it all in memory, actually. Yeah, I think that would be fine.
But then, you could write the sort of recursive thing of, say, give me the set of your children. Oh, let's think about this. One question you could ask is, do you have homogeneous children? And that can be recursively applied. If you don't have, you say, like, if all my children have the same schema that are files, and then if I ask the same question of my directory children, what is your common schema? And it's the same as my file children, assuming that you're allowing to mix files and directories, which maybe you're not in this instance. Maybe the leaves are strictly at the very, very bottom of the tree. But you could generalize both, right? But then, essentially, the A directories, am I homogeneous? Do I have a homogeneous schema? Is the answer to, are all my files the same? And if I have directories, are they also homogeneously the same schema? And then it sort of naturally falls out, and you could memoize that so that it's pretty quick and easy. And then, obviously, what you do is you start at the very, very top of the graph, and you say, are you homogeneous? And if it says yes, you're done.
Right.
There you are. Everything's the same at this point.
Right.
And if it's not, you say, okay, well then let me find all your children and ask them, are you homogeneous? And as soon as you find one that says yes, it is, that is the leaf, that is a root of a new tree that you never need to inspect further after that. Now,
so
obviously, it has
build up
recursed
the
down
tree, and then you do a breadth first search across that tree, looking for nodes whose children are homogeneous, basically?
Yes, and you can stop at that point. Obviously, you still are visiting all the nodes because in order to ask the question, are you homogeneous? Internally, it's going all the way down and back up again. But if you memoize it, then you don't have to hit the nodes more than once. So that would be a top-down way of doing it.
Is there a way to do this where you sort of do like an order and pass through the keys? Because piggybacking off of what the API from S3 is giving us is sort of like, all right, I'm going to iterate through all these keys, right?
Yeah.
And then along the way, I'm going to take each key, I'm going to do the inspection of the underlying data at that point, which is that is actually the most expensive part computationally, right?
Yeah.
There might be a million keys, but like reading all that data is the thing that's going to take a long time, right?
Yeah.
And inspecting the schemas. But you sort of inspect the schemas as you go. And my thought here was that maybe there's some efficiency to be gained from once you've detected a heterogeneous subkey, stop scanning. There's no point in continuing to do the super expensive schema inspection once you've detected something where it's like, oh yeah, this directory has 2 different types of files in it. It's got 1,000 files, but there's no point in checking the other 998 because these two are not the same.
Different. Yeah, that's very true. Yeah, so you could definitely, I mean, if I guess that's an error condition or an underspecification when we were talking about this to start with, which was, I was assuming that you could partition the world at some point. You could find these top rooted keys, but if you find a node for which its very leaves have mixtures, then that node is a bad node. Like you say, well, I can't do anything with this.
Right. Yeah.
But yeah, to answer your earlier question, to do this incrementally, I think so. Effectively, you given one long key string name and the results of what schema this is, you can of course create speculatively or look up if they already exist each of the nodes in the graph by splitting on the slash and then saying, okay, well, let's find the node that's like called Bob, and then the one that's called Ian, and then the one that's called Tracy, and then here is the 010403, and then here's moo.csv, which is where I am. And if there's a node there, if you've just newly created a node, then definitionally you'll say, well, at the moment the set of all schemas that I've seen is what I've just passed this schema to be. And if not, then and this is obviously a leaf node, rather a leaf directory. It has no further directories under it. You can write if you're writing the second second schema for that node. Like you said, that okay, this node has children, children that are stop. This is silly now. Any more things that land in this node, it's already poisoned. Don't bother looking at it anymore.
Yeah.
But if not, then you've constructed the graph, except the only thing you haven't done is you haven't filled in the directories that only have directories as children's schema sets. But that's fine, because that's what the second part of the algorithm is going to do. Once you finish going through it, the breadth first says, I don't have to look at the data anymore, because I already have the list of all the nodes, the leaf nodes, and whether or not they are poisoned because they have a mixture, or they have exactly one schema type. And then their parent, and you could potentially do this online as well, where you say, okay, every time I update a node's schema set, you can update its parents to say, like, hey, also, by the way, this is the second thing.
Like, I was thinking about this, and I'm like, I could do this by literally building a tree data structure, right? But I almost wonder if you could do this with like a hash map, where when you process a single key, you say, I'm going to create an entry in the hash map for this directory and each each of its parents, right?
I mean, what you're doing is you're storing a tree in a hash map, kind of implied, right?
Yeah.
But where there's no explicit nodes that like you can go up and down, because the way that you go up is to just like truncate your key and look at the hash entry for the bit that's like, so that would work as well.
Right.
Obviously, the entry there would be like the set of schemas.
Well, it's just the one schema, right? Because if you ever detect a conflict, you'd have to mark it as basically like no good. Right, so it's either the schema or a marker that says like this subkey is no good, right?
Right. Okay, but that wouldn't let you answer the question. Like in my original example, if you had the A and the B top level nodes, they would both, the root would be poisoned and say, no, I have a mixture.
But that's fine, because you'd have an entry in the map for A that was good, and you'd have an entry in the map for B that was good.
Okay, but you can't. If you just have those entries, how do you? Right, so you having filled in this hash map, how do you interrogate it? You need to know what the keys are, and you don't actually know what the keys are anymore. Right? If you had the tree, you know what the node of the root of the tree is, and you know from each node what children it had.
Yeah.
But you can't do that in the hash map without knowing the list of all those.
I mean, maybe I'm missing something here, but my thought was like, okay, at the end of that sort of happy path example, I would have A as an entry, and I would have B as an entry. And I would have an entry for each one of B's subdirectories, and each one of A's subdirectories.
Right. So you've got so in my example, you have A and B and all the dated directories and all those things underneath it.
Yeah.
So you've got a hash map with many, many thousands of entries. Were you just going to walk through the hash map in the random order the hash map's going to give you out the nodes that are in that hash map?
Yeah, and then from there, you look at the keys of the hash map and you find the shortest.
Right.
Like the highest level paths.
Right. So effectively, that's how that was the bit I was missing, was the fact that it's not necessarily that straightforward to go from here's a hash map of all of the keys to what's the shortest key? Well, now I have to go over every single entry in the hash map.
Yeah, it's like
an order n.
Yeah, it's like order n twice. It's 2n, right?
Yeah, as opposed to order n and then log n effectively, or n log n for not even n log n. No, it's just log n. I think for if you built the tree as you were going along instead of the hash map, then you just walk at the top and you get like the answer is at either the top node or that one of its second children.
Uh-huh.
Either way, I think if they're equivalent, it depends how many leaves you end up throwing into the hash map. I mean, I guess you don't have to store the actual files in the hash map. That's the trick here. You don't need to store their schema. You only aggregate them at the directory level.
Mm-hmm.
And so you are talking about,
and I think it would let you sort of abandon early, where it's like when you check a key, you say, okay, is this parent already in the map marked as bad? Because if it is, I don't need to inspect it. Right.
There you are. You turned an order n operation into an n log n.
Yeah.
I think no. Is that no? Because like for every n, you have to then go. Okay, there are potentially log n parents of me, and I have to check them as I go.
Yeah, but I mean, anything that lets you skip the inspection process is going to be worthwhile here.
Oh, but the inspection process would have happened when you populated the map.
Yeah.
The reading bit out of the end is the trivial part, right?
Mm-hmm.
So I think our algorithm then, putative or otherwise, is grab the big old list of full keys from the S3 APIs streaming through.
Mm-hmm.
Construct or look up, as you say, in this hash map, have I done some subset of these things already? And maybe if you find it's poisoned already, you just skip it.
Mm-hmm.
Right, if you've already found an entry that says, look, there are already 2 schemas somewhere along the list of that. Now, again, if you had a tree, you walk down the tree to where you are or walk up from the node you just created. But if you have a hash map, you break it and you look up those things, which again is they're equivalent, I think, right?
Yeah.
But assuming that so far you haven't found a node that has at least 2 schemas already, you go, well, now I need to see whether or not this schema either matches the one schema that is there, or if there is no schema there, I need to populate the entry with this schema. So now you know you're cursed to go and do a long lookup and read the data and pass through it and whatever. Chunk. You come back with a new schema, and this, if there was nothing there, you say, well, this is the schema of this, and then you walk up the graph and you say to all of the nodes there, hey, this is the schema, or you check against the schema to make sure that it's the same schema as any of the parents. And as soon as you hit 2, you know, well, this is poisoned now. We don't need to do this, anything under this point in the tree again. Which obviously means you're going to then run through the API kind of going list. But very quickly you'll go, yeah, this is I don't need to look at it. I don't need to look at the expensive part. Okay, so that's the walking process. And then at the very end, you look over the whole map and you find that, and then this is like where I say it gets more tricky. You go through all the keys and you try and find the shortest key that has not been poisoned. But then if you want to find the set of the shortest keys that are like separable and not poisoned, it's harder to do that, I think, from like just walking through the keys, because you have to essentially infer again the graph structure out of like breaking the key on a slash in order to say, hey, is this... Because it's not even shortest, right? You know, you could have 2 directories with longer names. One's got a longer name than the other, and you're like, it's not.
It's
the
not. Yeah, it's not shorter. It's like number of levels.
So I don't know if you're saving anything by having it in the hash rather than just accepting the tree is going to be part of your life. It's not that difficult, and you can answer the question a little bit.
Yeah, I mean, the only reason I would lean toward a tree is because it's like an out of the box data structure, and I need to do, I think, very little to. I mean, I guess the values are probably going to be reasonably complex. But anyway, that's like,
I don't know that they are even right, detail. You know, but that's that. The other thing that's worth thinking about this, if we're just talking in generalities, is that even scanning over that many files takes a long time. And if you were to do multiple parallel scans, one starting at A, one starting at B, one starting at C, or whatever, the usual tricks that one does to scan over S3's like list function faster, then I think both of these approaches still work. You might, if you have multiple threads, and if you're thread safe, like data structure or map, then you might occasionally do more work than you needed to, because there were 2 like threads that were both scanning files where a third thread discovers that actually this is a futile exercise, you know, that this point in the node is passed. But like, as long as you can handle that situation, you only ever do n pieces of extra work in the worst case where you have n threads, right? But in the good case, you are mostly able to parallelize on that. Although, to be honest, probably just scanning through is fast enough, and then you're going to be stuck doing the actual parsing, and that can be multi-threaded because you just have a work queue and say, "Hey, here's some things I need you to do. Go and get it done." And when you come back to me with the results, then I can fill in the tree.
Yeah. We were talking the other day actually about my efforts to scale this system horizontally, and that is one of the prime use cases of that work is being able to like basically delegate work out on a per key basis. Like, hey, could you scan the schema for this CSV file for me? It's probably going to take you like 3 minutes, but
I see.
Separate that out and then we'll do that work that way.
That's perfect. What a fun question.
I was going to say, so because this is Two's complement, the other thing that we can talk about here is the test cases. So
of course.
what tests would you write for this? And more importantly, maybe, what order would you write those tests in? Because like the most basic test, if I was going to I am about to sit down and write this. So,
right, this is literally I interrupted you from doing this.
Yeah. But the test I'm probably going to start with is if there are no files in the bucket, return me an empty list.
Right. This is sort of a zombie approach. Approach. 0, 1, mini.
Yeah. Exactly.
I forget B is.
We
can do this.
Boundary.
Bounds. Boundaries. Interface.
I'm just making words.
Yeah. Anyway, the trick is the ZOM part is test with nothing, test with one, test with a few of them.
Yeah.
So the first thing you do is say, hey, empty directory.
So like should return an empty. I'm just typing this out. List if there are no files, right? And that's easy enough to write. I just make an empty bucket using my fancy fake but kind of real in-memory bucket. It's not fake. It's a real thing.
Are you actually creating anything for an empty directory, though? I know you can in S3. You can create essentially an empty file that is the file that ends with the slash that causes it to be kind of
I didn't even know you could do that. That's terrible.
I think that's what happens if you're like in the S3 AP. Sorry, if you're in the AWS console and you make a directory and you then see this directory that's empty. Because otherwise, if you make an empty directory, the directory doesn't exist. It's like that thing in source control when you can try and create a directory and you check it and it's like, no, the file doesn't. There's nothing there because what we're tracking are files, not directories.
Right.
So I don't even know how you'd write that test.
Well, I mean, I could just make an empty bucket, right?
Right. Okay, so that's like just a completely empty bucket. Yeah.
Mm-hmm. Yeah.
And then assert that it returns nothing.
Yeah, and then assert that I get back an empty list. And then, of course, the next obvious one is I'm going to make one file, and I'm going to make sure that, I don't even... So here's an interesting thing here. Mm-hmm. I think a rookie mistake when writing that kind of tests. So,
you're about to describe the way that I'm doing it, aren't you? Okay, tell me what the rookie mistake is.
The rookie mistake when writing that kind of test would be to... basically unnecessarily test through into the schema inspection algorithm. The schema inspection algorithm is already written. There's already tests for that. And through you know that it works.
Transitivity of as long as you call the schema inspection routine with the right path,
right.
Trust that it works.
Right.
And so don't care about that bit. Don't.
Yes.
Yeah. All right.
That so bit, I'm going to write the test.
Pass the rookie test.
That's like. I'm going to write a file into this thing, and then I'm going to have it run the whole scanning inspection algorithm, and I should get back one schema. These are the things I'm going to assert, and these are the things I'm not going to assert. I'm going to assert that I got one.
Yep.
I'm going to assert that the path into the file is what I expected.
Yep.
I'm not going to assert the number of columns. I'm not going to assert the types and names of those columns, right?
Right.
Because that behavior is already tested. Now,
so that's interesting. I would have mocked that out, right? I don't know if that's where you're going with this. I would have said, okay, I'm going to completely and utterly, with my C++ mindset here,
right.
I would pass in the, and something which implements the interface of test this path, and then I would give it a fake one and say, hey, all I'm going to do is I'm going to record that you said that you wanted me to check this schema, and then I'm going to return you back the schema Bob or whatever, anything. Because at that level, I don't care what you're doing with that information because I'm already trusting that it's going to work. Whereas you're actually talking potentially about calling the schema code, but deliberately not looking at the results of it because you don't care about the results of it. You trust that they work. So equivalent, and you don't have to fake anything out, and you don't have to have an interface or anything, and you're already faking out the S3 at a very S3 level.
Yeah, right.
But Yeah. Okay.
Yeah, and that is a very sort of interesting point of debate, and I think there's lots of people that have different opinions on that. And I used to be more in the camp of like, I'm going to fake out the schema inspection algorithm. And these days, the way I think about it is like, if I can write this so that the test is fast, and the thing that I'm mocking out, or I would consider mocking out, the real one, doesn't have any outside interactions. It runs quickly. It does the thing. The phrase that I've heard a lot of through this is a sociable test, or testing through is another way that people describe this.
Yeah.
But it's basically like some number of hops, 1 or 2, or maybe 3. 3's a little much, but 1 or 2 hops down into the sort of dependency graph of the thing that you're testing. Generally fine, so long as you don't make so long as it doesn't have any other bad things. It's not
right. And to be clear here,
like
the sort of like the fakeable interface you're passing around here for S3 means that it's not like you're making TCP connections.
Exactly.
You don't have to and all that stuff. So you've already kind of said, okay, like that's the boundary that I'm prepared to draw. Right. And if I go 1 or 2 steps away from that sort of law of Demeter breakingly, then that's okay. I'm testing more of my system, but I'm also not going to rely on it because that is not the purpose of these tests.
Exactly.
And furthermore, if I break my schema detection system in some subtle way that doesn't matter for these tests, I don't want these tests to unnecessarily fail.
Exactly. You don't ever want the scanner, the sort of tree walker scanner code tests to fail because like, oh yeah, this CSV file doesn't have a comma in the right place or something like that, right? Like that's going to be a not informative test. You're going to be very confused as to how you possibly broke that, right?
Right.
So the assertions that you pick here basically are going to determine how much you're going to be able to use these tests to refactor versus how much you're basically just pouring concrete around your code, right? Because like the most like painful, I think, and people talk about this all the time. It's sort of like, I've heard people say, and it just makes my head explode. It's like, I don't like writing tests because it makes it hard to refactor, right? And I'm just like, oh my god,
wow,
it's really
very emotional. I know,
it's like
listener, you can't see him, but he's always crying here.
I hear that, and I'm like, you don't understand what any of those words mean. Any of them. None of the words in that sentence were correct. The trick here is like when you overspecify, right? And it sort of like comes almost from a good place. We're just like, I want to make sure my code works. I'm going to write lots of good tests, and I'm going to have lots of assertions and all these other things. And so, but the problem is when you overspecify, you're not sort of doing the core job of what the tests are there for. The tests are there for to assert that you have the behavior that you want, but they should be agnostic about the behavior that at that level of testing you don't care about. And this is exactly that, right? This tree walker scanner thing shouldn't care at all about whether or not the schema inspector is doing its job correctly. And if you overspecify those tests, you're going to make it harder when you come back later and you're like, oh, we need to change the way that the schema inspector works, right? And you go and you change it, and then you have all of these failing unrelated tests, and you're like, why are these tests failing? Well, because you overspecified, right?
Yeah.
So the dial here that you have to turn, and you really want to get it in exactly the right spot if you can, is to specify the things that you care about for this code that is under test and not overspecify this thing if you're going to do this sort of sociable style. Now, the other alternative here is what you were just saying, where it's like, no, I'm just going to mock that out. So you can change the schema inspector all you want. It's not going to break these tests at all. And I have a hard guarantee that that's not true. And there's lots of situations in which you might actually want to do that. But the what I'm about to embark on here in the next 20 minutes when we're done with this conversation is trying to set that dial exactly where I want it, so that I have the confidence that the code that I'm writing right now works without having overspecified into this thing that I already know works, that I already wrote tests for, that I've actually already used in other contexts. And I'm not coupling those things together.
So, one file. So when you said that, right, before you went off on this not even tangent, this is a very relevant thing.
This is a major soapbox moment here.
Yeah, it was though, and I'm glad you look very happy.
Stupid kids. Yeah.
But the thing that immediately sprung to mind after like one file is one file with varying number of subdirectories in the root, and then 12 different things. Because again, that's like a 0-1 many kind of thing, where it's like, well, everybody knows the edges, the boundaries. That's the B part of zombies, isn't it? Yeah, boundaries is like, well, if it's in a subdirectory, that makes sense. I'm sure I've tested that, but like, who thinks to put one of these files directly in the root, right? There's probably not what you're ever planning on doing. It'd probably be a mistake to do it, but like, that is where my instinct tells me a body will be buried there, and you'll find something interesting there. Just like, when having a file that's empty, which probably doesn't affect this in this particular case because you've already tested your schema tracker, but like, that would be another thing I think of as like, oh yeah, someone made a file, but it's not got anything in it, right? That's kind of like an edge, but that would be an edge case for your schema validation.
Yeah. And so the interesting thing about that test is I was having a conversation about this with our mutual friend, Mr. Pat Farley, yesterday, actually.
Patrick Farley.
Of the London Farleys.
Of the London Farleys.
Talking about how it is possible, especially if I'm not sort of like lazy enough implementing the solution after I write the should handle one file, right? If I'm like, I know how this should work, and I just sort of type it out. It is possible that I write that should handle varying subdirectories test, and it passes. Right?
Yeah.
And
I would hope so if you did it right, but
well, maybe. So that's the thing is if what I did is I took a step too far when I was making the implementation, and I basically wrote untested code, right? So I have this test for should handle one file, and I go in there and I don't write the most basic thing that I can think of. I don't write a simple thing. I write like, oh, well, this is what this algorithm needs to be. So I'm just going to type it all out, right? What I've done is I've written untested code, because almost certainly I could change some of that code or delete it or simplify it, and my test would still pass, right? And I might notice that if I go and I write that should handle varying subdirectories, and it passes. And the question that you could ask yourself at that point is, have I written untested code before, and now I've tested it, and now I probably want to make sure that the new test that I wrote actually covers those cases, and I might actually go in and like mutate that code and break it and make sure that it fails? Or is that test actually unnecessary? Obviously, that case is something we need to handle, but if that test doesn't drive out any new code, do I need it? Or maybe more realistically, do I need the first one that I wrote? Can I now delete the should handle one file? Because it's impossible to have an implementation that handles varying subdirectories that doesn't also handle one file. Right.
So that's a really interesting question, because there's like the code that I have just written, the implementation code that I know that I wrote in a particular way, and I'm testing that with knowledge, like very much of like how I'm driving out, like if you were going for 100% code coverage or that kind of nonsense that we don't really put much faith in. But you're like, oh, I have to handle this case because in my implementation, I treat them differently, or I don't treat them differently. And that would either drive these things, or like, oh, I didn't get 100% coverage because the if statement that deals with the, if it's in the root, it doesn't get covered. Right. So there's that kind of part, but there's sort of like a moral feeling of like, well, I've been doing this for 20 years, and I know where the kind of things where if I make a change to the implementation, I bet you I break this because of that. And then that's why those are more speculative tests, and maybe you have a stronger opinion about that. Because, of course, reasonable people could disagree about, like, well, no one will ever do that thing.
Right.
And you're like, what if they do, or what if they change the implementation in a relatively straightforward way that might take advantage of either knowing X or Y, right?
Exactly,
it's the one file, and there's more than one file kind of thing.
Yep. And that is...
So...
That is just a judgment
where
call.
It's an art form, isn't it? Right. This is art, not science.
It's because you're speculating on what the behavior of future humans will be. That's basically what it is, right? Like, I'm going to add these tests here, not because they drive out any code, right? I could delete these tests, and I would still have all my code existing code very well thoroughly tested. But I'm adding these tests because I'm scared of future people, maybe future Ben, who had some comments left for him, coming in and changing this code in what would be a reasonable way, but breaking something that wouldn't then be covered, right?
Yep.
And that, like you said, it's an art form. It just comes from experience. Really, it just comes from making mistakes on that decision.
Yeah, and going,
and then going,
God,
I should have done it different. Yeah, that would have been
right. I mean, let's say, like, you're writing a string library and you're testing, adding two strings together should return, the strings, by the way, and you just know yourself that, like, I've realized that the empty string, I should probably make sure that I test adding an empty string to a string. So I'm speaking from experience here, this kind of stuff, and like, well, how could you implement string concatenation where you break the empty string concatenation? And the answer is, well, if you're writing an optimized version in assembly, I guarantee that you haven't put the check in at the beginning of that to say, oh, hang on, if it's 0 to start with, because you just immediately want to pick up n bytes of the string and do this kind of stuff. And so that's the kind of thing where, like, you are definitely locking in, you're hedging for the future of, like, well, this is this is like the kind of mistake I can see myself making down the line, and or it's almost part of the documentation at some level as well, of like, well, these things should work.
Yeah.
The interface allows for you to do this. It's surprising, but it does allow for you to do this, and maybe I should just leave this here as like a boundary condition of the interface to say this is fine. So
yeah. And one of the other things that you need to consider with that, in addition to sort of guarding against future mistakes, is the thing that we were talking about earlier about, like, writing those kinds of tests can also lead you to accidentally overspecify, right?
Right. Yeah.
Like you're testing things that are either behavior that you don't necessarily really care about, or testing through into other dependent modules or classes or functions.
That's a really fascinating one, actually. The testing things you don't care about. I have definitely been guilty of that before, where I have thought to myself, I really want to make sure that this thing works, but I don't really know what the answer should be.
Right.
And by writing a test, I've kind of mandated that is what the answer needs to always be.
Exactly.
And maybe I didn't want to do that.
Right.
But then I also don't want to have a path through my code that but then maybe that's a question for, like, well, fix the path through your code, throw an exception instead. I don't know what. Do something else to say, like, hey, you're in uncharted territory here. Don't do this.
Right. I mean, like, an obviously wrong example of that, like, bounding this problem a little bit, like an obviously wrong example of that would be like having something that produces a set and then you make an assertion about the order, right?
Yep.
Right? It's like, you don't care about the behavior. You don't care about the order of the set. Why are you writing a test for it? It's like, well, because I wanted to know what it is, right? Or I wanted to specify it, or what is it? It's like, no, like, we are intentionally leaving that unspecified, and that has value. The fact that it's unspecified has value, right?
Yeah.
It allows us to change our mind later. So, like,
exactly, the hash map thing
right.
you talked about, right? Exactly, is a perfect example of that. Like, when you write the code, the test that's going to iterate through the hash map and then build its world from the hash map entries in the order that they just happen to landed in the hash map, then you're definitely way into the world of, like, well, I don't even know what sequence these things are going to happen in, so I can't be too critical of the answer. Yeah, that's interesting. Well, you better go and write this code now. We've been talking about it for 40 minutes. I gotta get back to work. You gotta actually go back. Yeah, I'm gonna crack the whip on you. And maybe we'll catch up with this another time and see how it turned out, whether or not any of these algorithms actually worked or not.
I like that idea a lot. Cool.
Well, we'll hear about it next time, perhaps.
All right, next time.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.